Alright, today we're going to talk about stars. I'm going to start out with just kind of a little generalization about stars. I want you guys to realize the sun is the closest star to the earth because that's our solar system. Okay, so sun is the closest. However, the next closest star or grouping of stars it kind of is Alpha Centauri. Now, Alpha Centauri is a group of 3 stars. Yes, some of the stars occasionally are closer to us, but on average it's pretty much 4.2 light years away. Now, a light year. What is a light year? Well, a light year is the distance that you would travel if you traveled at the speed of light for 1 entire year. Now, the speed of light being 186,000 miles per second. Okay, roughly, give or take, 300,000 kilometers a second. Okay, so extremely fast is the speed of light. That's going around the Earth about 7.5 times around the equator in 1 second. Okay, so that's just how fast light is. Now, realize you travel at that speed constantly for 4.2 years. That's how far away Alpha Centauri is. It's really far away. Okay, so what I want you to realize, the next slide that I'm going to show you, you don't need to copy down. Okay, you can I just want to show it to you, so don't worry about copying it. Now, how far away is Alpha Centauri? Well, that's what I'm showing you right here. Knowing that the speed of light is 186,000 miles per second, Alpha Centauri is 4.2 light years away, and then just some statistics that we're going to need for the equation: 365.26 days in a year, 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute. We go ahead and do the calculation. We take the speed of light, 186,000 miles a second. Now, since it's in seconds, we got to eliminate the seconds because we're trying to figure out exactly how many miles away it is. So, 60 seconds per minute, seconds cancel out. 60 minutes per hour, minutes cancel out. 24 hours in a day, hours cancel out. 365.26 days in a year, so the days cancel out. And then 4.2 light years, so the years now cancel out. So this is the distance to Alpha Centauri. That whole number right there. Hundreds, thousands, million, billion, trillion. Just over 24.5 trillion miles away. Okay, that is the closest star to us at 4.2 light years away, besides the sun. Now, yeah, the closest star or solar system, because each star has its own solar system. You know, whether there's planets in there or just comets or asteroids, you know, there's all sorts of different things that could consist of making up the solar system. But that is the next closest star or solar system to the Earth. Okay, the sun. The sun is the name of the star that's in our solar system. That's just its name. Okay, each of the stars that you see out there in the night sky, they are pretty much just like our sun. Our sun is just kind of an average one. But anyways, they're composed of hydrogen and some helium. Okay, 90-some% of hydrogen, less than 10% helium. Okay, but they're gaining more and more helium all the time because what's taking place is we have the fusion, which is combining 2 different atoms of hydrogen into a helium atom that creates or gives off energy, and it produces a huge burst of light, which is sunlight. Okay, so you take 2 hydrogen atoms, fuse them together, and that creates 1 helium atom. Okay, now sunlight travels at 186,000 miles a second, like we said before, but at that speed, we are far enough away from the sun that it takes 8 minutes, a little over 8 minutes, for sunlight to reach the Earth, which is 93 million miles away. Okay? At 93 million miles, it takes 8 minutes for sunlight. So it's not going to happen, but if the sun went out, or let's just say, example, solar flare. You were watching with a solar filter on a telescope, and you were able to see a solar flare that happened. You would be seeing that solar flare 8 minutes after it really happened, because it took it that long for us to be able to see that light to travel to us. Now, our weather and ocean currents are caused by the sun's energy. Life as we know it, life would not exist on Earth if the sun did not exist, because that's our form of energy. Okay, so now just some little bit of information about the sun, its life expectancy. The sun is 333,000 times the mass of the Earth. Okay, so it would take 333,000 Earths to equal the mass of the sun, and it's just composed of gas, hydrogen and helium. Okay, the diameters. The sun is 1,392,000 kilometers across. Okay, the Earth is 12,756 kilometers across. So that would make the sun 109 times the diameter of the Earth. Meaning, if you took the Earth and lined each Earth up side by side across the sun, it would take 109 Earths just to go across the diameter of the sun. Now, the sun is somewhere in the ballpark 4.6 to 5 billion years old. It's expected to last for about another 5 billion years before it goes into its next stage, which the next stage is a giant. We'll talk about the stages of stars a little bit later on in our next unit, next section, I mean. But that is when the sun goes through some major changes. But it'll take about another 5 billion years. So it's roughly halfway through its life expectancy, pretty much. So we don't have to worry about it any time in our near future of going out or something catastrophic happening to it. Okay, last thing here is I just wanted to tell you guys a little bit about sunspots. We're going to be doing a lab in class on this, but only the sunspots are cool areas on the surface of the sun. Cool, yeah, I put that in quotes because relatively speaking cool. 3,000 to 4,500 degrees Celsius. Okay, that's what we mean by cool. Okay, versus 6,000-7,000 degree temperatures on the surface of the sun on average. These spots migrate or move across the surface. That helps us prove that the sun rotates, because as you see these spots moving across, that's the rotation that we're seeing. Okay, a cycle from high to low and then back to a high again. That's a complete cycle going from its peak down and then back up. That's one complete cycle. Typically lasts about 11 years. Okay, sometimes it's a little bit less, sometimes it's a little bit more, but it averages out to be about 11 years. Okay, now the last thing is the sun has these major solar flares. Some of them are much bigger than others, but these are the hot spots on the sun. They're really major explosions. Okay, great big, huge kind of pieces that kind of come up from the sun. Yes, it's still gases and stuff like that, but that's what a solar flare is. They're many times the size of Earth. I mean, you could take a few or stack them right up on top of each other. I mean, some of the biggest solar flares are many times the size of Earth. Okay, so explosions bigger than Earth. Temperatures of millions of degrees. Okay, so they're really hot. Okay, sometimes these solar flares can actually cause some interference with satellite communication, cell phone communication, some different things like that. The other big thing that you can see from solar flares is we can see the auroras. Aurora borealis in the northern hemisphere and aurora australis if you're in the southern hemisphere, but the solar flares can cause those auroras to interact with our magnetic field of the Earth and create some pretty neat light shows. Okay, So Alaska seems, Alaska and those areas seem to, in the United States, seem to be able to see most of them because they're farther north and they have more hours of darkness in the winter. So, all right, we'll talk about this more in class.